All right, we're going to talk about truth tables. And truth tables are often given without a context. Okay, but I will start with a statement and then see if we can make sense of a truth table by looking at our statement. So here we go. No calculators for this one, just a few highlighters if you have it. So if you have the statement, Caleb attends every math class and gets 100% in math, the conditional statement would be if Caleb attends every math class, comma, then he gets 100% in math. Okay, that's a statement there. So we turned just a regular statement into a conditional statement. So that's the if P then Q. So we're basically whatever follows if is P and whatever follows then is Q, right? So that's important. So let's fill out a table here. And I have 4 cases for you because there are only 4 possible cases with a conditional statement, all right? I've already laid them out. So one of the cases is where both parts, P and Q, are actually true. And then the next case is where both of the P and Q, the hypothesis and the conclusion, are both false. So those are your first 2 cases. And then one case is where the first part is true, the second one is false. Fourth one is where the first part is false, and then the second part, Q, is true, okay? So an example would be, let's say Caleb actually attends every single math class. So that would make P true, right? And then he indeed gets 100% in math. Both are true. We know that that is a true statement. That the statement stands. There's nothing wrong with that statement. Let's say Caleb does not attend every math class, right? So the first part is false. And because of that, right, does not get 100%, both of them would be false. It still would make the statement true. There would be nothing wrong with that statement. This is the problem case here with conditional statements. If the first part is true, but what follows the then is not, that's when you have a false statement. So example would be, let's say Caleb attends every single math class, so that's true. But then he ends up not getting 100% in math. And technically, if I made that statement, I've lied, right? Because the condition was met, but then what follows was not, right? So that's a false statement. And that's the anomaly. We'll talk about that in a bit. The last case is that the hypothesis is false, the conclusion is true, where let's say Caleb does not attend every single math class. Just doesn't happen. But he still gets 100% in math. Technically, this statement, there's nothing wrong with it. You still haven't lied. It's just that Caleb did not attend every math class. But getting 100% or not, that's still fine if he does get 100%. So that would be a true statement. So I want you to circle or highlight the row, the case where a conditional statement is false, right? It's when P is true and Q is false. So when the arrow goes from P to Q and it goes from a true part to a false part, you have a false statement, okay? And that's like the main starting point here. I want you to understand that these cases, to be honest, they're flipped all over the place. Like they're never going to be exactly the same, but you're going to be given 4 cases. There are only 4 cases, but in the order, they could be in any order. You would want to look for, if you see, hey, the arrow goes from P to Q, it's if this, then that. You want to look for the arrow going from the true to the false. And when you find that case, that is your false statement, and everything else gets a true. Everything else is actually okay. It's just that one case that is a false statement, okay? So remember that. Let's go and do the contrapositive right next to the conditional. Because if you remember, the contrapositive and the conditional statement actually have the same logical veracity. Okay, they're logically equivalent, and I'll show you that here. So let's write it out. Contrapositive is where you flip P and Q, right? So Q comes first, then P, and you put a not in front of both of them. So if I have this conditional, I would start with this. If he, so we can say Caleb here, right? If Caleb does not get 100% in math, then he did not attend every class. Sorry about my spelling there. Okay, so that's how you would write it. And so what are these nots here? What are they? Basically, whenever you have one of these squiggly lines or a bar on top, it means you negate the original. It's basically saying not Q. So what is Q? At the beginning, it's true. So if you negate it, you turn it into a false. If you go to this part where Q is false, if you negate it, a double negative turns true. Okay? So you're essentially just switching everything over to the opposite. So if it's true here, if you put a not in front of Q being true, it would be false in that first case. Right? If it's false here, it'd be true there. That's what negating does. So we've copied this over, switching it all. Okay? Not P, right? You go to the P column here, the original, and you would essentially just switch that around. Right? If it's true, then it's false. If it's false here, then it's true there. Okay. So now let's look. Where do we have? So we want to see from not Q to not P. So it's perfectly set up in this situation where it's easily visible. The only case where you go from true to false is here. So this is the only false statement. Everything else is true. And you can see them side by side where, right, it's case number 3. Those are, in both instances, the false statements. So everything else lines up. So they're logically equivalent when you put them side by side. All right, next. You'll see that the converse and the inverse are also logically equivalent. Okay, so I'm going to go logically. So they sound different, but they're saying the same thing. All right, next, converse and inverse. So let's write out the converse. The converse when you just flip the original. So that would be if Caleb gets 100% in math, then he attended every class. Okay, that's the statement. And again, you're flipping. It's Q to P, right? And I'm going to have to zoom back up here. So basically what we're going to do is we're going to take our Q here from the very beginning and copy that into this section. So true, false, false, true. Okay, so I copy this in here. And then we copy P in here. And why am I doing that? Because it's easier to see. okay, what we're doing. You don't have to do it. You could have just gone back to that original table here to look at all 4 cases, but I'm actually flipping these columns, and now we're going to see the arrow goes from Q to P. Where is it false? So this would be true, true, true. This is where the statement is false, right? When the first part is true, where the arrow starts, and where it's pointing towards, if that part is false, which is this case, the whole statement is false, making everything else true. Again, look for the anomaly, find that one, then everything else is true. Then you don't have to think about it if you just remember this one. Now, I want you to know that you could have looked at this conditional statement and just gone, it goes from Q to P, right? The arrow technically goes this way if I look at this table. So where is, this is true, true, false, 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 true, true, false. It's that 4th case where it should have been false if you have it as a converse. And that is exactly the case here, okay? Inverse is not P and then not Q. So basically we go to the original and says if Caleb does not attend every math class, then he does not get 100% in math. That's what it is, okay? So again, it's saying not P, not Q. So let's go back to the original here. What does not do? It basically changes a true statement to a false. So we're going to go false, and then the second would be true, and because this is true, this would be false, and because this is false, this would be true. And then not Q, you go back to the Q here, and that would be not F, or sorry, F, T, T, F, right? And so you're looking, when you're supposed to fill in this truth table, right, you go from not P to not Q based on this, and the only time you have a false is at the very end there, that 4th case. Everything else is true. So again, they're logically equivalent. And by that I mean that the converse and the inverse are logically equivalent, and the conditional and the contrapositive are also logically equivalent, okay? That's something worth adding to your study sheet. So conditional and contrapositives are essentially saying the same thing. Converse and inverse are also essentially saying the same thing. So let's practice some, these were if-then statements, but we have truth tables that involve and or. And I want you to know that and, this symbol when you do truth tables is like this. It's kind of like when we did the sets, right? It looks like a U upside down or like an N. Or is like this when you do truth tables, when we do logic statements. Okay, remember that those symbols, have them on your study sheet. If you're given a statement with and, there it is, both parts need to be true for the statement to be true. So, for example, Angela wants to go shopping and watch a movie afterward. Let's say you say, I'm going shopping and watching a movie. The logic notation would be like this, with the and in between. And think about the statement. The only time you will not have lied is if indeed both of these are true. You did both of these items. If you only did one of them, like say you go shopping but you don't go watch the movie, even though you said you would, you've lied. Let's say you don't go shopping, you only watch the movie, you've still lied. The only time is when both are true. So for and, right, true and true is the only time the statement is true, okay, for an and statement. So let's look at, so it's asking us, hey, fill in the true or false for this statement, knowing that P and Q are as follows. So you have the 4 cases. So you look, right? True and true. This is the only statement that would be true. Everything else is a lie. You've lied, right? If you didn't do either one of them, of course you've lied. If you've only done one, but not the other, you've also lied. So that's the anomaly with an and statement. Okay. Or statements. Okay. Or goes like this. One of the parts needs to be true for the statement to be true. So Angela wants to go shopping or go watch a movie. So if you say, I'm going to go shopping or watch a movie, as long as you do one of the 2 things that you've mentioned, you are fine, right? So if you don't go shopping, you only go watch a movie, well, you haven't lied because you said or. If you do both, well, you definitely haven't lied because you said you were going to do one of them. But if you fail to do both, then it's an anomaly. So for an or statement, if both are false, then the statement is false. So I would write down, like, for an or statement, this is the anomaly. So everything else is true. So let's go find where it's false and false. It's right here. So when you fill in one of those tables that involves or, you go find the anomaly, and then everything else ends up being true. Let me go back here to this. I'm going to go up here. True and true is true. All else, false. Maybe that's a good one for and. This is for and. Okay. For or, false and false is false. All else is true. Have that on your study sheet. And this is or, right? Or statements. And then next, last one is the biconditional, if and only if. I'm already over time. I know that, guys. Sorry about that. It's 17. Basically, for biconditional, I will say this. False, like if it's, you're looking for where both parts are false, then it's going to be true. Or where both parts are true, that is also going to be true. So these are the 2 that are easiest to find. All else is false. That's biconditional. So it's basically when you have a statement like this, the only time you're not lying is when both parts are false or both parts are true. So true, true, if it's a biconditional, this would be your true statement. False, false, that would also be your true statement. Everything else is false. I mean, it's half and half, right? And the reason being, if you think about it, biconditional, the arrow goes this way and this way. So let's look at case number 3. If you were to go from P to Q, if P then Q, true, false, that would be a false statement, right? Back to the conditional, right? If you go the other way, true to false, right? Then you would also have a false statement. So that's why these 2 are false. And where you have the true, true, false, false, those statements are true. So basically, both of them have to be the same for this to be true. And I know you're scratching your head a little bit, but I'm going to make this a separate, you can stop and try this. I will add it to the video. I will make another video where I go over this so that, you don't have such a long